Questions 1 through 10 on the 2020 Grade 10 AMC 10B. What is the value of? So we have 1 plus 2 minus 3 plus 4 minus 5 plus 6. So 1 plus 2 minus 3, that cancels, and then we have 4 minus 5, which is negative 1, and then plus 6 would be 5. So number 1, the answer is D. Carl has 5 cubes each having side length 1, and Kate has 5 cubes each having side length 2. What is the total volume of these 10 cubes? The total volume is 5 times the first side length cubed, and then 5 times the side length 2 cubed. The volume of the cube is the side length cubed. So this is 5, and this is 5 times 8. Therefore, that's 5 plus 40, and that is 45. So number 2, the answer is E. The ratio of W to X is 4 to 3. The ratio of Y to Z is 3 to 2, and the ratio of Z to X is 1 to 6. What is the ratio of W to Y? So they want you to find W over Y. Well, W over X is 4 over 3. So that means W is equal to 4 over 3 times X. Then they tell me that Y to Z is 3 to 2. Therefore, Y is equal to 3 over 2Z. And then finally, they told me that Z over X is 1 over 6. So that means Z is equal to X over 6. Now W and Y, it'd be nice if I could have them both in the same letter. W I have in terms of X. So let's get Y in terms of X. I think I can do that. Y is 3 over 2Z, but Z is X over 6. So there we go. That would be X over 4. So Y is X over 4. And there we go. That will give me basically what I need because the X's will cancel. So invert and multiply, and we get 4X over 3 and 4 over X. And the X's do cancel, and I get 16 over 3. So 16 over 3, and therefore number 3, the answer is E. The acute angles of a right triangle are A and B, where A is greater than B, and both A and B are prime numbers. What is the least possible value of B? So we have some right triangle. I have no idea what it looks like, but let's just say there's the triangle, and we have A and B, and A is greater than B. Now obviously, since the sum of the angles of a triangle are 90, and we already have a 90 degree, the other two, A plus B namely, must add up to 90. And they're also saying that both of them are prime. Okay, so this is where you have to test out your knowledge of prime numbers. If you've memorized them all, I always recommend to memorize at least the first 100, or for the prime numbers within the first 100 numbers. So all the primes that are between 1 and 100, it'd be nice if you could memorize those. And those, of course, start with 2 and 3 and then 5 and 7 and kind of goes on from there. Now, we want two prime numbers to add up to 90. And we want the B to be as small as possible. We want the least possible value. Okay, well, the smallest prime is 2. And if I put that, this one would have to be 88. But 88 is not a prime, right? Okay, what about 3? Well, that is going to give me 87, and 87 is not a prime. Now what I'm going to do is probably just reverse it to make it the big one being A and the small one being B. So we already did 2 and 88, that was a bust. We did 3 and 87, that didn't work. How about 5? 5 and 85, well, that doesn't work. 85 is obviously divisible by 5. How about 7? That gives me 7 and 83. 83 is a prime. This is a prime, this is a prime, and B equals 7 is the smallest possible value of B I can get with the conditions of the question. So number 4, the answer is D. How many distinguishable arrangements are there of 1 brown tile, 1 purple tile, 2 green tiles, and 3 yellow tiles in a row from left to right? Tiles of the same color are indistinguishable. So we have 1 brown, 1 purple, 2 green, and 3 yellow. So that's what? 1, 2, 3, 4, 5, 6, 7. So 7 spots. And we have to make whatever combinations. Okay, so from the 7 tiles, I'm going to choose one spot. One of these spots I'm going to choose to put the brown tile. So wherever it is. Then from the remaining 6, I'm going to choose one of the spots to put the purple. And then from the remaining 5, I'm going to choose 2 of those spots to put the green. And then I've got 3 spots remaining. I'm going to choose all 3 to put the 3 yellow. And this will give me the number of combinations. So that's 7 times 6 times 5 choose 2 is 10. 3 choose 3 is 1. And that is 420. So number 5, the answer is B. Driving along a highway, Megan noticed that her odometer showed 15951 miles. This number is a palindrome. It reads the same forward and backward. Then 2 hours later, the odometer displayed the next higher palindrome. What was her average speed in miles per hour during the 2-hour period? 15951. What is the next palindrome? Well, the ends most likely are going to stay as 1. It'd be nice if I could have 5, but then I won't be able to get something greater than this, because something greater than that won't happen. If I put a 0 there, obviously that's less than the previous number. So I'm upgrading to 6s. And I think if I put a 0, that should be the very next palindrome. Okay, so what is the difference here? 15951 and 16061. That has a difference of 110. And it took 2 hours to travel that distance. So speed is equal to distance over time. So distance is 110, time is 2 hours, and that is 55. So number 6, the answer is B. How many positive even multiples of 3 less than 2020 are perfect squares? Well, if a number is positive, well, obviously it's greater than 0. If it's even, it's going to be of the form 2n. If it's a multiple of 3, it's going to be of the form 3n. So combining these two, 6n would be a number that satisfies both criteria, that it's even and a multiple of 3. Okay, and then we want that 6n to be a perfect square, so some perfect square, k squared. Well, a perfect square, as I'm sure you know, is 2 numbers multiplied by each other. The only way this can be a perfect square is if n has a 6 in it. So it's got to be something 6 and then something else. That something else also has to be a perfect square. So it's got to be, say, m squared. So I hope that makes sense. Otherwise, this 6 will be all by itself, and 6 is not a perfect square. So there has to be a 6. So that means it's got to be 6 times 6 times some m squared. Like that. So that's basically 36m squared. And that is the conclusion as to the form of the number. Okay, and it's going to be less than 2020. So any number of this form that's less than 2020. So let's see what happens. Let's make a little table. M 36m squared. When it's 1, I have 36. When m is 2, I'll have 4 times 36. So 36 times 4. When it's 3, I'll have 36 times 9. When it's 4, 36 times 16. And these are all perfect squares. All these guys here. I encourage you to test them out. 36 times 25. 6 would be 36 times 36. 7 would be 36 times 49. And then 8 would be 36 times 64. However, that is 2196, so that is the first time we exceed 2020. And remember, we have to have numbers that are less than 2020. And the only ones that are less than 2020 are these guys, and there's 7 of them. So number 7, the answer is 7, and that's A. Points. PQ lie in a plane with PQ equal to 8. How many locations for point R in this plane are such that the triangle with vertices PQR is a right triangle with area 12 units? Okay, well, we got to figure out how we're going to do this, and the best way, of course, is with a diagram. So I'll put in the first one. I'll just draw the first one, actually. Let's say we have P and Q, and it's got to be a right triangle. So this is R. That's one way. Another way, of course, is to change the location of R and put it there. So we have 2. Okay, that's an answer choice. But you can also flip it. So you can also do this kind of scenario. This remains P and Q, and now that's R, and of course we can flip that one also. So this remains P and Q, and this is R. Okay, we're now up to 4. Am I done? Are there any more? And interestingly, the area doesn't really matter. It's irrelevant to, we need to figure out how many orientations are there. Well, so far I have 4. And that's illustrated really nicely by this diagram, exactly the way I drew it. They've got 4 in there. And here's the first one. Here's the second one. Here is the third one. And here is the fourth one. All right, so think about it. Are there any more? And the answer is yes. That is a scenario where the right angle is not at P anymore or not at Q anymore. The right angle is at R. So how do we do that? It would be basically like this. So this is the right angle. This is R, this is P, and this is Q. And in a very similar way, you'll be able to draw those 4 times as follows. And this diagram illustrates that. So here's the first one that I drew. Here's the second one. And then you flip them and you get 2 more. Here's a third one. And of course, here's the fourth one. So, interesting question. So that means 4 and 4, 8 is the answer to number 8. And that would be choice D. How many ordered pairs of integers x, y satisfy the equation x to the power of 20 plus y squared is equal to 2y? I don't think there's any actual formula. I think we just have to plug and play here. So let's just make a little table and off we go. Okay, the first one, I'm going to start with 0. Let's see what happens when I put x equal to 0. When I put x equal to 0, that just vanishes, so I just get y squared is equal to 2y. So I'll bring this over and factor, and that will give me y and y minus 2. So y can be either 0 or 2 when x is 0. Okay, let's try x equal to 1. Let's see what happens. That's going to give me 1 plus y squared is equal to 2y. This is going to be a quadratic, and let's see if this factors here. 1, 1, y, negative, negative. So y is obviously 1. How about when x is negative 1? Let's see what we get. That's going to be 1 again, I believe. Negative 1 to the power of 20 is just 1. Okay. So that's going to give me the exact same. 1 plus y squared is equal to 2y, and then very similarly, it's just going to give me that y minus 1 is 0, so y is 1. All right, and I think that's it. Because they have to be integers. Okay, that's good. If I go up to, say, 2 for x, this is going to be absolutely gigantic. And I don't think you'll get integer solutions. So number 9, therefore, it's just these 4. And that would be choice D. A 3/4 sector of a circle of radius 4 inches together with its interior can be rolled up to form the lateral surface of a right circular cone by taping together along the 2 radii shown. What is the volume of the cone in cubic inches? All right, a little bit of a 3D kind of interpretation you need. So it's practice, so just get out a piece of paper, make this shape, then tape these edges together and see what you get. Absolutely nothing wrong with doing that. And the volume, therefore, of the cone, if you remember the volume formula, it's 1/3 pi r squared times height. Now, when you do make this shape, I'll attempt to draw it here. It's going to look something like this here. It's going to look, obviously, it's going to be a cone. So something like that. Now, our task is to figure out what are the dimensions of this cone. So let me just draw in these dimensions, and I'll talk you through it. So when this is taped to that, that represents the side, this guy right here. So that side is 4. This is the height, and this is the radius of the base of that cone, or the circular part of that cone. So how do we get the h and the r? Because obviously those two values are needed. This represents 3/4 of the circumference of this shape, but it represents essentially the entire circumference of that. So what is 3/4 of that circumference? Well, 3/4 of the circumference. Circumference is pi times diameter, and the diameter of this guy is 8, since the radius is 4. So we have 8. So that's basically just 6 pi. So 6 pi is the circumference of that. So circumference is equal to pi d, which can be also written as 2 pi r. And we just figured out the circumference is going to be 6 pi. So 6 pi will be 2 pi r, and that leads to r is equal to 3. So put that in there, r is 3. And now we can easily figure out h using Pythagoras. 8 squared plus 3 squared will be 4 squared. So 8 squared is what? 16 minus 9, which is 7. So h is root 7. All right, so we have everything we need to figure out the volume. 1/3 pi r, which was 3, and then h, which is root 7. So that looks like 9 divided by 3 is 3, so 3 root 7 pi. Number 10 would be C.